very good morning, good afternoon, good evening to all my dear friends. Welcome to TQM 2 lecture series under NPTEL MOOC, and I am Raghunandan Sengupta from the IME department, IIT Kanpur, and this is my first lecture for TQM 2. So, obviously, it will be more of a slow build up of what the concepts will be utilized as a background for TQM2, and we will continue discussing the same issues and go into the main topic of TQM2 total quality management, which will basically be the big chunk would be the later part of TQM1, which I have already taught. So, later part would be the design of experiments and the related issues. But for design of experiments, as you will slowly come to know what it is, how it is utilized, why it is important, I will also cover initially for at least few lectures the background of statistics, which would be required very intensely for the design experience. And for this background material, which we will start today slowly and steadily, I would later on, as we proceed, once we do the lectures for today, I will also give you the references. Now, references why I am not immediately giving is that I do not want all of you to basically pay too much attention on statistics and lose the main flavor, which will be TQM2. So, let us proceed slowly, and the related information for TQM2 will slowly be given to you as we discuss the TQM2 lectures. Number 2, this is, as you all know, it will be for 20 hours. 20 hours would basically mean there would be half an hour lecture each, and in each week there would be 5 of such half an hours. So, that would basically make 40 lectures. For 40 lectures would be spread over 8 weeks. Each week, as I initially said few seconds back, it will be 5 lectures in each week. There would be also after end of each week lecture, there would be assignments. So, in totality there would be 8 assignments, and as per the NPTEL MOOC norms, the questions would be as you had faced for TQM1, and obviously there would be end term examination also for TQM1. So, with this simple background, I would slowly start TQM2. Another thing which was the point which was mentioned by the students, asked by the students in the forum, whether the notes would be available or the slides would be available for TQM2, and they did ask about TQM1. I did, considering there are some IPR issues, I would not be sharing the notes for TQM2, but obviously all related discussions, everything can take place in the forum, and myself and my teaching assistants and all the set of people who are helping with their whole heart and soul for this TQM2 will definitely answer all your questions, whatever it is there. So, this is the first class for TQM1, as I said to you. Now, we will as I said, this is not the syllabus. What I am saying that this is the background to be covered. So, once the background, the main so called preface is over, then will come the introduction for TQM2, and slowly we will proceed. So, we will cover, and now let me tell you, the coverage would be done in such a way that we would not be going to direct theoretical results. We will only come to the practical sense that what are the distributions and what are the different backgrounds of the combined distributions we will consider, and why we are considering that would become apparent when we start the design of experiments. So, background to be covered would be elementary probability theory, conditional probability, Bayesian concepts, discrete continuous random variables, functions of random variables, which would be combined along with the third point, which is discrete and continuous random variables, sampling theory, which is the main portion which will actually give you a sense why these are important in TQM2. We will go for method of statistical inference, which would basically be divided into 3 broad areas: point estimation, interval estimation, hypothesis testing, and main part obviously everybody will understand later would be interval estimation and hypothesis testing. Software languages which would definitely be encouraged for all of you to understand would be MATLAB, another would be R. This is a free software, so obviously you can download and use this for different type of work related to statistics. One is SPSS and another is SAS. So, obviously SAS is also good package, but R is basically gaining its foothold as a freeware software and everybody use it, and there is a huge amount of input which is coming into R to develop it very fast. And now, the word statistics is derived from the Italian word stato, which means the state, and statista basically refers to the person involved with the affairs of the state. So, basically there was a person in during the old times and Renaissance and after and before that. So, people used to collect data related to land acreage, data related to population, data related to tax, data related to, say for example, how many such births and deaths had occurred, and all these things were important for the king to basically keep a note of how things were. So, based on that it slowly evolved into a big field of statistics. Nowadays statistics, which basically said in the plural sense, is the study of qualitative and quantitative data from our surrounding, and the surrounding can, or the system can be anything which from where we can draw meaningful conclusion. It can be related to the uses of, say for example, some fertilizer being used on the paddy field to get higher yield. It can be related to what is the average height of the students who are in a class. It can be related to the marks of some examination which have been conducted throughout India. It can be, say for example, some chemical process is being done in a factory, continuous factory, and products are coming out, you want to basically test whatever it is. It can be anything. It can be related to, say for example, pollution control, you want to find out what is the total amount of sulfur with suspended particles which is there in the environment. Based on that you want to do a study, you collect the data. So, this is would basically mean the general study of the data and statistics. It also means in the singular sense the body or the methods that are made to draw meaningful conclusions from such data which you have collected. So, the main steps in the study of statistics would be method for collection of data, can be primary, secondary, scrutiny of the data, presentation of data which is non-frequency, frequency data, and so on and so forth. Main steps to continue further would be the analysis of data through statistical methods and models. They can be methods related to regression, they can be methods related to Bayesian statistics, they can be methods related to, say, estimation, they can be methods related to inference, the methods can be related to general methods of movements, methods can be related to Newman-Pearson lemma, whatever it is. There are different type of concepts would be used, and from there you basically draw some meaningful conclusions from the results, and then if needed modifications of the methods are required in order to basically use them in much more practical sense. Descriptive statistics can be presented as non-frequency and frequency data, but we will consider morely the frequency ones, but I wanted to mention you that what are the different two big broad lines. So, frequency data is one of them. Frequency data can be of basically different type. So, in basically we will consider the box plot, very simple, and why we are going to consider a box plot, it will become very apparent, because that will give you a lot of information about how the quantiles are, what the distribution looks like, what is the level of confidence based on which you are doing the studies, and so on and so forth. So, we will consider a box plot is a set of 5 summary measures which will be considered. It would be related to the median. Obviously, median and mean would be different, because depending on the distribution, median and mean can be different, and they will give you 2 different sets of information. It can be the lower quantile, it can be the upper quantile, it can be the smallest observation, largest observation, or say for example 90th position observation or the 10th position observation, whatever it is. Based on that we do the studies. Now, whenever you are doing a statistics or study related to so-called a set of observation is there, we want to pick it up. The question will come that why do we need a set of observations? That is the first one. And if you do not need the set of observations as it is, should we basically collect the information from all such observation which are available? Now, the word come means that if you mean by the all set of observation, does it mean that we have a huge infinite so called population from where we want to draw some inference? So, now the word of population will be described, and as I describe the word population, you will understand the statement which I just made a few minutes back. So, population would basically be consist of the set of all such measurements in which the investigator is interested. So, say for example, I want to find out the number of people who have taken the JEE main examination in India in 2000, say for example, not in India, I am using the word India, why I am saying that, I will come to that later. JEE main examination held in 2016, because maybe JEE examination 2016 or further on may be held throughout the world. So, if I want to have basically a look at the whole population, it would mean the whole number set of students who have taken JEE main that year. Now, if I want to say for example, find out that what is the performance in one of the subjects physics, or I say for example, I want to find out what is their average weight, or I want to find out what is the average height. So, technically I have to basically pick up the observer set of information from each and every individual or entity in that whole population and do my study. Now, that may be not advisable in the sense that if the population is infinite, then picking up a set of information from all the set of infinite such observation is practically impossible, or it may be very large that it would basically take years and years to collect the data. So, in that sense what we do is that we take up a small piece of chunk from the population which we mention as sample, and do our studies from the sample in such a way that it gives us some meaningful conclusion of the measurements which we wanted from the population, which means the characteristics of the sample should be such that it will give us the maximum set of information with the least amount of error from the sample, from the population. Now, in that sense, example can be, as I said, the students in the city of Kanpur, the population is also called the universe, and the population will be denoted by the symbol capital N. Now, obviously, you will say that I did mention the population can be infinite, but that is just a concept which is true, but in case if the population is huge, not infinite, but is huge, then obviously it will be denoted by capital N. Now, sample is a subset of measurements selected from the population. Sampling from the population is often done randomly. So, but there are different ways of how you do it randomly, such that every possible sample of size n, that means the sample which you are picking up, the number of points or number of observations which are there in the sample is of size small n. So, to continue reading, such that every possible sample of n elements which have an equal chance of being selected, and that is what generally randomness, what I mean in a very simple sense. A sample selected in this way is called the simple random sample or just a random sample. Example can be, continuing with the example which we gave or which we just discussed few minutes back, for the whole population being capital N and the population being the number of students in Kanpur city. So, for this sample, the example can be the students in Kendriya Vidyalaya inside IIT Kanpur campus. So, that would be the sample, and as I mentioned that it would be denoted by small n. Now, whenever you are deciding something to do with the population and the sample, there would definitely be two sets of informations which will be required. Now, what I mean by this, to illustrate that, I will discuss that slowly. That may not be very important for TQM, but they are generally important for the background which I said. Now, whenever you have basically a population and when you have basically some set of information, consider this: I want to do some experiment. So, the experiment can be either rolling of the die or basically picking up some chits marked in a box. Consider the rolling of the die is an unbiased die, faces are marked 1 to 6, or when you picking up chits, the chits are each marked only one number starting from 1 to 100. Or say for example, a very third simple example can be when you are tossing a coin and it is an unbiased coin where a head and a tail are there for the coin. Now, whenever you are doing that, you are presupposing that the event or the experiment which you are doing is unknown to you beforehand. So, that is why you say it is a random variable which may vary, and that is denoted by a capital variable which is capital X or capital Y, whatever it is, the denotation. And once the experiment is done, the overall random variable becomes realized to us. So, hence we denote it by a small x or a small y. Now, it does not mean that we know small x and small y beforehand, we only know what are the different type of the values which are available for capital X, and based on the so called frequency, that how many number of times they occur in a set of such trials which you are doing or such experiments you are doing, it will basically mean that what is the so called frequency of the number or their number which is coming up. There means, say for example, if I am rolling a die, the random variable, to give that example, random variable will be x, which is whatever the face is coming, and when the first face comes 1, I assign capital X as small x, which is 1, and basically try to find out what is the number of such frequencies or small 1 would be coming out in some number of trials which I am doing by rolling the die. Now, when I have the set of informations for all the small set of variables which are there for small x, it would mean that there is a chance. Now, the word chance I am using for the first time, and then it will go into the concept of the relative frequency, and then finally go to the concept of probability. So, this is the way I am going to handle it. Consider this, I keep tossing the coin, I do it 100 times, maybe I do it 200 times, whatever it is. So, some number out of 200, some number would be head and some number would be tail. Now, in that case, consider for 200 number of tosses, about say for example 101 of them are heads and 99 of them tails. So, obviously, I will see the chance of the relative frequency is in one case 101 by 200 and another case is 99 by 200. So, we keep repeating it, do it the second time 200, note it down, do it the third time again 200, note it down. This 200 is not sacrosanct, it may change, obviously I can increase it. So, as I keep repeating it and as I find out the so called frequencies and the so called chances and the so called relative frequencies is the ratio, number of times it is favorable divided by the number of such experiments which I had done, which in the first example just I gave would be 101 by 200, or for the other head or tail it will be basically 99 by 200. So, as I continue doing it, slowly I will find out that the so called average, I am using the word average in a very in English word sense, not in the statistical sense. The average so called relative frequency would basically be one fixed value. So, for the unbiased coin it will be half and half, that means half for an head and half for a tail, which means that if I actually toss the coin a huge number of times, half of them would be head and half of them would be tail. So, that would basically mean that is the actual probability of getting that random variable based on, say for example, some probability distribution which is there. So, I am using the word probability distribution also for the first time. Now, when I am mentioning the word probability distribution, one thing should be remembered that this probability distribution can be of two types. Two types means conceptually, I am not saying the whole frequency concept would change and you will have different types of approach to solve that. It would only mean that in a very simplistic sense that the random variable which I am trying to study can be either discrete or continuous. So, say for example, let me this two example which I gave for tossing a coin or trying to basically roll the die. The random variable when I am tossing the coin can be either head and tail, and to head I can assign one number, to tail I can assign another number and do my experiment. when I am rolling the die, the random variable can be either the number 1 or 2 or 3 or 4 or 5 or 6. So, obviously, they are discrete, but in the case when, say for example, I am trying to find out the flow of a fluid in a pipe per unit time, then the flow of the fluid in the pipe, consider effluents are coming out from a factory into the background of the factory where they will be processed, and then basically pollution control and all these things would be done. In that case, we will technically consider the flow is such that it is continuous random variable, or say for example, I am trying to find out the so called height or weight of individual. I will consider technically that the height and the weight can be basically continuous, and they can take any variables. Say for example, weight I am considering is between for jam bottles, or say for example, I am filling up sauce bottles or trying to basically find out some packaging which is being done, and the weights are between, say for example, 9.89 till, say for example, 10.05. So, obviously, all the values between these would be applicable, and they would be considered as a random variable which are continuous. Now, when I am taking discrete or continuous random variables, obviously, they would be a so called probability distribution assigned to the continuous or the random variable which is discrete. Now, in this case, we say for a discrete and random variable, the probability distribution is generally known as probability mass function, because they are all concentrated on the masses based on what are the realized values of x. And when I am considering the probability distribution function word, then it means that this basically PDF. So, for the mass function, it will be PMF, and for this case, it will be probability distribution function PDF for the case when x is basically continuous. Now, whenever I have the discrete case and the continuous case, I should always remember the corresponding values which I am trying to calculate. So, those are basically some function, which means that x takes a realized value, whether discrete or continuous. I put it in that equation, which is the probability mass function and the probability distribution function, and then I would basically get a probability. So, the probability would obviously be between a value 0 to 1, both inclusive, which will give me the so called concept of the relative frequency of the occurrences of that random variable when it takes that realized value, whatever the realized value, like when I am tossing the coin, it can be head or tail. When I am rolling the die, the numbers can be either, as I said, 1 or 2 or 3 or 4 or 5 or 6, and basically we do the experiment. Now, the interesting part is that this probability mass function and probability density function would basically, if you add up all the values. So, what I mean by the word add up all the values would basically mean that I am the PMF or the PDF of the summation for all those values starting from the minimum value of x to the maximum value of x, whatever it is. Say for example, for the case of the coin, it is either head and tail. So, there are two values. Say for example, for rolling the die, it is 1, 2, 3, 4, 5, 6. So, if you add up all the probability mass values, they would be 1. In the case when we basically adding up all the in that word adding, it will be now integration, because it is a continuous random variable. When I try to find out the continuous random variable summation of the PDF values, the PDF values basically should sum up to 1. So, this concept, when I am trying to find out the so called PDF or the PMF summed up from minimum x value to some values of x, not the maximum value, because the maximum value, if you add up all the values, it will be 1, as I mentioned, to some value of x, that would basically be known as the cumulative distribution function, means the cumulative value of the distribution function, whether PMF or the PDF, for the case from all values of x minimum to that value of x, which we are interested to find out. So, coming back to that, this slide is there in front of us. I gave it very briefly, because these things may be applicable. Obviously, everybody would have done so called probability in class 12 or in BCom or BSc or MCom, and definitely in engineering or whatever subjects which you have done. So, they would basically would have taught you the concepts of probability, relative frequency, then probability mass function, probability density function, and the cumulative function, distribution function. So, that is why I kept talking about and trying to basically give you a flavor of what we mean by frequency distribution, PMF, PDF, and the cumulative distribution function. So, the cumulative frequency corresponding to the upper bound on any interval class, that means interval class is basically the word which I mean is basically keep adding up all the values till that particular value of x where you want to find out the the sum of the PDFs or the sum of the PMFs. So, as I continue reading it, it basically means to the upper boundary of any class or interval or value in a frequency distribution is basically the total absolute frequency of the all the values less or greater than the boundary of the class or the values. So, it can be both ways. One thing I can keep adding up all the PMF or the PDF values from minimum to that x value. Another can be that basically I add up all the so called relative frequency, which is basically probability for all the realized values such that the realized value are greater than particular x till the maximum value of x. So, it means I am basically taking either from the minimum to that x or from the from x to the maximum value. So, obviously addition of them would be 1, as I mentioned, that if I add up all the probabilities from the minimum to the maximum, the probability has to be 1. Probability is basically the so called ratios of the frequency to the total numbers or the relative frequency. Now, in this case this CDF value can be defined from the set. I am again repeating from the x minimum x to that x whatever x value which I have, and then continuing from that x to the maximum value is basically would be the complementary so called values which are there, which when you add up they basically make 1. Now, to give an example, say for example, you are trying to find out the so called cumulative values of the probabilities for rolling a die for all values of x. X means the phase which is coming from 1 to say for example 4. And so, in that case we know the probabilities are 1 6. So, I check up the values of x till 4 inclusive of 4. Let us consider inclusive of 4 would be 1, which is 1 by 6, 2 is again 1 by 6, 3 it is 1 by 6 and 4 is 1 by 6. So, the whole cumulative values would be 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. So, we get the value of 4 by 6. Now, if I call it say the statement which I just mentioned few minutes back about the greater than type cumulative frequency, it will mean that I am basically adding up all the values for the probability for x values being realized greater than 4, which means 5 and 6, which will be 1 by 6 plus 1 by 6. So, the total cumulative frequency would be 2 by 6. So, if we add up 4 by 6 and 2 by 6, it becomes 1, which means that means addition of all the PMF or the PDF values basically is 1. So, continuing that, we denote the cumulative frequency of less than and greater than type as described here. So, this would be, so this part, the one which you have here would be for the less than time, that means I am adding up all the values. So, if you see this sign, I will highlight it. So, this will be the one for the less than time, and then the other one which I will try to highlight, this will be for the greater than type. So, obviously that would mean this part where I am now hovering the pen would be for the values 1, 2, 3, 4 for rolling the die, and the other values would basically be 5 and 6 for trying to basically find out the sum of the probabilities for values of 5 and 6. So, with this I will end the first class and continue the discussion of TQM initial background, and slowly we will come to the design of experiments. Thank you very much and have a nice day.